Welcome to the most mind-blowing show on YouTube. Are you ready to go back in time and witness the birth of our universe? Buckle up, because we are about to explore the Big Bang, the beginning of everything. Alright folks, hold on to your hats because we are about to go on a wild ride through time and space. We are talking about the Big Bang, the moment that started it all, the explosion heard round the universe. And just to set the record straight, it wasn't a bang like you are thinking, more like a massive explosion that created everything we know and love today. And it all went down around 13.8 billion years ago, which is older than some of the oldest grandparents, some of the youngest dinosaurs, and even older than the oldest bottle of wine. To put it in perspective, if time was a pizza, the Big Bang would be the dough and we are just a sprinkle of pepperoni on top. The Big Bang theory states that the universe began as an incredibly hot and dense state, where all matter and energy were contained in a single point. This explosion created space and time, and as the universe expanded, it cooled down and particles began to form. These particles eventually formed atoms, protons, neutrons, and electrons, the building blocks of everything we see around us. It's like baking a cake, the ingredients are all there, but it takes time and heat to make it into something delicious. But it's not as simple as that. Scientists have found evidence that the universe went through a period of rapid expansion, called cosmic inflation, in the first fraction of a second after the Big Bang. This period of inflation is thought to have smoothed out the universe, making it homogeneous and isotropic, and also responsible for the formation of the large-scale structure we see today. Imagine it like this: the universe is like a big ball of dough and cosmic inflation is like a rolling pin. It smooths out all the lumps and bumps to make it nice and even. But, don't be fooled, the mysteries of the universe are still waiting to be unlocked, like dark matter and dark energy, the nature of cosmic inflation, and the beginning of time itself. But one thing is for sure, the universe never stops surprising us, and that's what makes it so exciting. Alright folks, we've covered the beginning, now it's time to talk about the universe's teenage years. You know, that awkward phase when it's trying to find its place in the world. And by that, I mean the expansion of the universe. As the universe expanded, it cooled down and particles began to form. These particles eventually formed atoms, protons, neutrons, and electrons, the building blocks of everything we see around us. It's like the universe was playing a game of Lego, but instead of plastic blocks, it was using subatomic particles. Now, you might be wondering, is the universe still expanding? And the answer is yes, it is. In fact, it's expanding at an accelerating rate, as determined by observations of distant supernovae. This acceleration is thought to be caused by the mysterious dark energy, which makes up about 68% of the universe's total energy budget. That's like the universe is on steroids, expanding at an ever-increasing rate. But it's not just the size of the universe that's changing, the universe is also getting colder as it expands. This is known as the cosmic microwave background radiation, a faint glow of light that fills the universe. It's like the universe's afterglow, the remnants of the intense heat from the Big Bang. This radiation has been measured to be around 2.725 degrees above absolute zero, that's minus 270.425 degrees Celsius. Now that's cold, colder than a polar bear's toenails. In summary, the universe started as an incredibly hot and dense state, and has been expanding and cooling down ever since. The building blocks of everything we see around us formed as the universe expanded, and it's still expanding today at an accelerating rate, caused by the mysterious dark energy. And it's getting colder, as seen by the cosmic microwave background radiation, a faint glow of light that fills the universe. And that's just the tip of the iceberg, there's still so much more to discover about the expansion of the universe. But for now, let's just sit back and enjoy the ride. Alright folks, we've covered the beginning of the universe and its teenage years, now let's talk about the universe's toddler years. You know, that phase when everything is happening really fast and it's hard to keep up? Well, that's exactly what cosmic inflation was like for the universe. Cosmic inflation is a theory that states that the universe underwent a period of rapid expansion in the first fraction of a second after the Big Bang. Think of it like the universe's growth spurt. It expanded so rapidly that it smoothed out all the wrinkles, making it homogeneous and isotropic. It's like the universe was wearing a really tight shirt and cosmic inflation was the iron that got rid of all the creases. This theory was proposed to explain some of the puzzles in the Big Bang theory, such as the horizon problem and the flatness problem. The horizon problem asks why the universe is so uniform, even in regions that can't possibly have interacted before the Big Bang. The flatness problem asks why the universe is so close to being flat, when a slight deviation would have made it either collapse or expand at an uncontrollable rate. Cosmic inflation solves both of these problems by proposing that the universe underwent a rapid expansion in its early stages, smoothing out any wrinkles and making it uniform and flat. Scientists have found evidence for cosmic inflation in the form of cosmic microwave background radiation, specifically the B-mode's polarization pattern. This pattern is thought to have been caused by gravitational waves generated during cosmic inflation. It's like finding a fingerprint at a crime scene, it's evidence that something happened. In summary, cosmic inflation is a theory that states that the universe underwent a period of rapid expansion in the first fraction of a second after the Big Bang, smoothing out wrinkles in the fabric of space-time, making it homogeneous and isotropic. This theory was proposed to explain some of the puzzles in the Big Bang theory, and scientists have found evidence for it in the form of cosmic microwave background radiation. So, next time you are ironing a shirt, just think, the universe went through the same thing, just on a much grander scale. Wow, that was quite a journey, isn't it? We've just covered 13.8 billion years of history in just 4 minutes. And yet, there's still so much to discover about the birth of our universe. The mysteries of dark matter and dark energy, the nature of cosmic inflation, and the beginning of time itself, are still waiting to be unlocked. But one thing is for sure, the universe never stops surprising us, and that's what makes it so exciting. Thanks for joining us on this journey, and don't forget to subscribe for more mind-blowing content.